Good morning, students. Students, in our experiment number 1, we did the titration of sodium carbonate versus HCl. And if you remember, we took HCl in the burette, sodium carbonate solution in the conical flask. We titer by adding the methyl orange and obtain the titer value when the pink color solution is obtained. Now, this experiment number 2 is again having a similar procedure. I mean to say, we'll be conducting the experiment in a similar manner, but the strength of the solution has been changed along with their numbers. So in this experiment number 2, in this experiment I will not be demonstrating to you because the procedure is going to be same, but the calculations will be different. So in this I will be explaining to you how to do the calculations of this experiment number 2 for the asked questions. Am I clear, student? Now here in this titration of experiment number 2, object, here you have been provided with two solutions, C17 and C18. I have changed the numbers over here. C17 is N by 10 HCl solution. I mean to say 0.1 normal HCl solution. In the previous experiment, it was molar solution. And C18 is a solution which is prepared by dissolving 7.1 gram of hydrated washing soda, that is Na2CO3 XH2O per liter of the solution. So we have in this experiment the two solutions. C17 is a N by 10 solution of HCl. C18 is a solution which is prepared by dissolving 7.1 gram of a hydrated sodium carbonate solution per liter of the solution. Procedure again will be same. You rinse and fill the burette with dilute acid solution and pipette with the sodium carbonate solution. Again the process will be same. You clamp the burette in the burette stand, fill it with the dilute HCl solution, pipette out the sodium carbonate solution into the conical flask. To that add methyl orange solution, and then in a dropwise manner we add HCl solution to the sodium carbonate solution till the persistent permanent pink color is obtained. So procedure I am not demonstrating to you, it is same as was in the experiment number 1. So what you will do over here, procedure, rinse and fill the burette with the dilute hydrochloric acid solution which is C17. Wash and rinse the pipette with the given sodium carbonate solution which is C18. Pipette out 20 ml solution of sodium carbonate into clean conical flask and add about 2 drops of a methyl orange into it as we did in the previous practical. Now run the acid solution C17 from the burette in a dropwise manner into the conical flask, shaking it permanently till the last drop gives the permanent light pink color. And you have to repeat the same process at least thrice so as to get at least 2 concordant reading. Am I clear? So student, I am not demonstrating experiment number 2. It is to be done exactly in the same manner as was demonstrated in the experiment number 1. I again repeat, in the burette we will take hydrochloric acid solution. In the conical flask we will pipette out the sodium carbonate solution. To this we will add a methyl orange solution, and then we add from burette in a dropwise manner HCl solution into the sodium carbonate solution till the permanent persistent pink color is obtained. That will be the end point of the titration. You have to repeat the experiment at least thrice to at least get the 2 concordant readings. Am I clear? Now the desired equation for this second titration will be Na2SO3, Na2CO3 XH2O plus 2 molecule of HCl will give twice NaCl plus X plus 1 H2O and the molecule of a carbon dioxide. In this second experiment, the questions are changed. You have to calculate the normality of C18 solution. C18 is a sodium carbonate solution. We have to find out the normality of this. Then the molecular mass of sodium carbonate X molecule, hydrated sodium carbonate, which is to be deducted from the experimental data. And number 3rd, you have to find out the numerical value of X. So this X is to be found out. That is, the water of crystallization has to be found out. And 4th, we have to find out the concentration of a carbonate ion in the C18 solution. So I hope these 4 questions must be very clear, which is to be calculated after carrying out the titration and obtaining the titer value. You have to calculate the normality of C18 solution up to 4 decimal place. So up to 4 decimal place, the normality of C18 solution is to be found out. So you have to find out the normality of C18, molecular mass of hydrated sodium carbonate, numerical value of X, and the concentration of a carbonate ion. The procedure, I hope, must be very, very clear. Now we will explain how to calculate. So how to calculate? First will be the observation table. The size of pipette used is 25 ml. Then you have to make this table, because in the board examination, tabulated work is being credited with the marks. So it will be the initial reading, final reading, and the volume of the acid solution used and the titer value. The first initial reading is 0, final reading will be 25.5. So volume of the acid used will be 25.5 minus 0, it will be 25.5. Similarly, you will perform the second practical, again obtain the titer value, it comes to be 25.4. In the third titration, you will again, in the third way, when we conduct the experiment again, the third titer value will be obtained as 25.4. And you may see over here, there are 2 concordant values obtained over here. So in this case, 2 common values are obtained, and that will be the end point of the titration. So titer value will be 25.4. Am I clear? Now students, you have to calculate for the questions which was asked, which was the first question, normality of C18 solution. So we have a formula of normality of dilution, N1V1 for HCl will be equal to N2V2 for sodium carbonate. C18 is a solution of a sodium carbonate over here. So this will be, what is the normality of HCl given? N by 10. What is the volume of HCl used as per the titer value 25.4? Normality of sodium carbonate is to be calculated. What was the size of the pipette? 25 ml. It may be possible that when you come to the lab, we may give you the 20 ml size capacity pipette. So then you will be making the calculation with the 25 or 20. Then N2 will be equal to 25.4 upon 250, it will come out to be equal to 0.106 normal. So is it clear? So this is how the normality of HCl will be, sodium carbonate will be obtained. So first question in the calculation is clear. Second question is, you have to find out the molecular mass of a hydrated sodium carbonate. How will you find out the molecular mass? We know in the normal solution, molecular mass will be equal to, if you find out the molecular mass of this one over here, so this will be equal to equivalent mass multiplied by 2 for the sodium carbonate over here. So how to find out the equivalent mass? It will be strength upon normality. What is the strength of sodium carbonate given? 7.1 divided by 0.106, and we obtain it as a 69.88. Am I clear, student, over here? Now we find out the molecular mass. It will be equivalent mass multiplied by 2. So it will come out to be equal to 139.76. Now how will you find out the value of X? Formula is Na2CO3 XH2O. So this will be 106 plus X into 18. What is the mass of sodium carbonate coming? 139.76. On solving it out, X will come out to be equal to 2. So what is the water of crystallization coming over here? Water of crystallization comes to be equal to 2. I hope you must be understanding this. Then concentration of a carbonate ion. What is the mass of sodium carbonate? 144 gram. Hydrated sodium carbonate. It contains 60 gram of a carbonate ion because the value of X has been obtained to be 2. So 144 gram of sodium carbonate dihydrate contains 60 gram of carbonate ion. 7.1 will contain how much? 60 upon 140 into 71. It will come out to be equal to 2.958 gram per liter. So this is how the calculations for the questions which are asked in the question number 2 is to be done. I hope you must have understood this. We'll send you this in your class group also as a calculation. The virtual video of this as a demonstrative work has been done with you in the experiment number 1. Now with this we have completed the 2 practicals of yours in the class 11 syllabus. We expect you to make the practical notebook of the same. We'll meet again in the next lecture with some other discussion. Till then, thank you.